We will hear from Szilárd, Széll and Katja Saarela from Eficode.
They will unpack what it takes to build trust among AI agents and why even machines struggle with communication problems and self-doubt.
From quality assurance to Oracle problem, they will show us what happens when AI starts managing other AIs. Let's welcome Katja and Szilárd.
Thank you so much. It's great to be back, right? I know some of you. You know me. I spent quite a long time in this building and before in the other building, so it's really great to be back. It's a personal achievement. But today we are not here to talk about us. It's to talk about AI agents and how to build trust into AI agents. But before that, who we are and where are we coming from? So we are from Eficode. This is a company originally born in Finland. The company has done DevOps before the DevOps term was coined. And we are supporting our clients to improve in software development practices, bringing AI into their practices, but really from service design into ITSM using the different tools, Atlassian, through all the cloud providers, helping all the businesses to be more efficient. So, am I? No, Katja, this is you now.
Yeah. So I'm Katja Saarela. I come from Eficode Finland. I'm head of DevOps and AI. I have done different kind of leadership and management tasks in many decades already, and I'm especially interested in different kind of transitions and transformations. And this AI is for me a really interesting thing because many things are changing here. It's not just the technology, but also humans need to learn new skills. And I'm especially interested in this kind of AI upskilling. So, and I think that it's not enough that AI is accurate and answers correctly, but we also need to think about ethical AI, transparency, explainability, and trust. And I did my PhD on these topics. My topic was how to predict work disability risk using machine learning. And I also think about those ethical aspects of AI.
Oops. It's okay. And I'm Szilárd, Széll. I'm a collector. I'm collecting experiences, collecting workplaces, right? Collecting certificates, but mainly collecting Lego sets. I'm a tester by life, and I've been in software quality assurance for 25 years, but also in transformation as well, helping companies to change, scale the agile framework to DevOps, to different ways of working. And yes, I'm being tested by my teenager daughter. So today we would like to talk about AI. And of course, you probably heard this kind of phrase already a few times.
So how do you feel? It is said that there will be a greater change in the next 5 years than it was in the last 40 years. During the lunch break, I really had fruitful discussions. We were thinking about those times when you really need to carry on your testing equipment. And that was only like 20 or 30 years ago. But it said that in next 5 years, there will be even bigger change. You can doubt it. But especially when I started to work with my PhD work 5 years ago, I used deep learning, NLP, and now 5 years later, those technologies are already history. They are in museums because Gen AI is going so rapidly forward. So let's see what happens. But I still think that there's a huge change happening, and that is something I love. So there's a huge opportunity that software development will be more efficient, more easy to do, as we heard today. Even juniors can develop code, but the challenge is that can they then be senior coders any day? There's a huge opportunity, but there are also threats, there are worries, fears. The reality is not yet there. AI is not used in so much that it could be in companies.
When we are talking to companies on how to introduce AI and what are actually the kind of maturity steps, we are talking about this 5-step model. So in phase 1, you enhance your developers, you enhance your workforce with AI, right? It's like the AI assistants, it's some productivity improvement. In phase 2, you start to have AI-powered software agents. So these are still working alone, together with the developers, together with everybody within the software development lifecycle. So not talking only about coding agents, it's everything else as well. But these are still single agents working with a rather predefined workflow. When we move on to phase 3, it's like orchestrated, AI-orchestrated software lifecycle. There are multiple agents which work together in an orchestrated workflow. And then when you go into phase 4, which is the AI integration level, product and business workflows are all integrated. You have the agents, they are running your workflows, your business processes. And I'm saying your business processes, because what's your company? Your data is already in the cloud, right? Your knowledge is already in the cloud. Your company is actually the way how you work, the mindset, the processes, and the behaviors of the people. Now, this is what you want to put into an agent. But this is what you want to put into an agent and not asking others to do that for you. And this is where we believe is the key. You have to understand your processes. And then you build on phase 5 this AI native software lifecycle business transformation AI factory, as we call it, where the agents are pretty autonomous, calling each other based on their description, based on their capability, and the agents work together to produce from idea a solution and check if the solution is provided. This is innovation. This is when you have an idea and you want to see how it works when it's deployed. Now, agents will capture the idea. Maybe, an agent sitting on a call with the customers, they have a problem, and this problem phone call triggers the whole system of agents, understanding the problem, figuring out how to solve it, developing the solution, deploying the solution, testing it, yes, and then having it in production, deploying, keeping it there, and running the solution. And if it doesn't work, roll it back, because we have DevOps under us. So this is how we see the movement. Many companies are on level 1, or maybe even thinking about level 1. A few is already on phase 2, but the big opportunity is on phase 3, phase 4, and above. Oops, too many buttons. So a bit talking about, okay, now nice, dreams, beautiful, vision. How do we get there? What do we need? We want to talk about how to integrate AI into the workflows. So if we oversimplify, and seriously oversimplify the picture, what is this? You have an agent, you have an input, and you have an output, right? Easy as that. But we have the communication problem. What do we want from the agent to do? I have several conversations with my wife, luckily. Sometimes half of that conversation is actually happening in my head, and I'm just telling her something. And she's looking at me like, I'm not in the context. Like, what you want, please repeat what you just went through in your own brain. Now, AI is the same. You have to communicate properly. You need to give all the context. You need to make it know what you know, think, assume, and believe that it knows. So communication problem is really important. One colleague of mine, or actually a teacher, a coach of mine, said that communication is done by the listener. If the listener did not understand what you want to communicate or misunderstood that, communication did not happen. Now, it's the same with agents. If the agent does not understand what you want, communication did not happen. Now, the other side of the coin is the Oracle problem. What good looks like? AI agents and AI is stochastic, right? You don't know what it will do, and it will never repeat itself. It will do something else. How do we know what is correct? And this is just, again, the good old testing Oracle problem. What's the expected result? How good looks like? We need to know that, and we need to build this goodness into our AI agents. And someone build goodness into the timer, please, because that's just gone out. So Oracle problem is to know what needs to be done and what needs to, how the things should look like. So if we put these designing AI agents and agentic systems, on the left side, we have the communication problem, and for that we use context engineering, and whatever it will be named, because until now it was prompt engineering, then context engineering, and next week it will be something else. But it's about giving the task and adding the input. And then the correctness is provided through a proper agent design, designing the agents, and also by the AI architecture platform and layer that is supporting you in the technology and with the technology to build these agents. But before we go into that, let's learn a little bit about the LLMs and the AI behind.
Yeah, how are they working? So as you might know, that LLMs are just text predictors. There's an example sentence: Michael Jordan plays the sport of, and the LLM tries to guess the next word. And the biggest probability is for basketball. So that is the correct answer. And that is how it works. So LLM compare the closeness of concepts. In the first example, we have cat and kitten, and then we have dog. And we can see that cat and kitten, they are more closely each other than cat and dog. And then the second example, we have man and woman. And if we think about two concepts like king and queen, they should be approximately same on same distance than man and woman. And that is how the LLM works. It just calculates the probabilities for those different words, and it estimates the distance between those concepts. It doesn't know anything, just using this data from the model that it has learned, and then gives those probabilities and selects the one that has the biggest probability. So they are quite dumb, actually, not so wise. But there are also another kind of problems too. We know that you can ask same question from the LLM, and several times you will get a different kind of answer, or then you also can get the answers that are ridiculous. So there's no reason for those answers, and they are hallucinating. We still have a lot of problems in LLMs, and but somehow we still need to provide results that are correct. And how to build this trust in those LLMs and in those AI agents that are using those LLMs. There are actually different aspects of trustworthiness. First of all, the answer must be correct. We are aiming for truthfulness. Those models must be safety and fair also. And we are looking for robustness it could be so. It's of course important that we will get similar answers every time. And privacy. We have legalization and compliance that we need to follow to get privacy. And one important thing here is machine ethics. I studied AI ethics, but here we need to use the word machine ethics because those AI agents, even if they are virtual and just lines of code, they are also machines like cars. And we need to think about the whole area of machine ethics when we are looking for trust. So let me introduce our little helpers, our AI agents. We have in our AI agent demo, we have 6 different agents working together. We have Bob, who is product owner agent. Then we have Sarah, who is DPO agent, and Quincy. He's taking care of test architect tasks. And with him, we have Tom, who is helping with testing. We also need Jan and Dave, and they are software architect and software developer agents. And those 6 agents are working together in our agent orchestration workflow. If you think about those maturity models, as Szilárd told, we are not in AI native level. This is like a level, is it like level 3? 2 or 3. So we have 6 agents, they are working together, but we still need human in the loop. It's not automatic. But the building of software starting from the idea from human. And then the next one is this PO agent who splits this idea into pieces, into requirements. Then the next part is for Sarah, who is taking care of the security. She's checking the security of the requirements. And those requirements we give to next agents. We have the software architect who is doing implementation specification, and then we will have a test architect who is doing test design. And on the next phase, there will be 2 agents. Software developer agent will implement the code, and then test developer will test that it is correct and quality is on certain level. And then the whole software is done, and of course we hope that it was something that we wanted, that it's similar to our original idea. But that is our agent orchestration workflow. So here are our agents again. Would you like to hear more on some of those agents? You can select one. Who would be the most interesting agent?
And this is about saving time, so please.
Software developer, okay. So we hear more on Dave. So what is Dave's role in this workflow? So Dave will implement features and run also unit tests. So typically unit tests are on the desk of the software developer, and also our Dave, software developer agent, will take care of those unit tests. Dave clones repositories and switches the relevant branches, and also take care of what files are going to modify based on the new features for the software. Dave will write the code, run those unit tests, and also update those Jira issues we've done, actually that we got from our product owner agent. So that is what is Dave's job, but next we will hear from the building blocks of the agent.
Yes. So, it's important to start with your value stream and with software development lifecycle. How do you do your job? And we are talking here about software development, right? But if you are in any other type of job, any other work, you need to understand your workflow. The value delivery, value stream mapping. We go back to the good old DevOps or process improvement ways with value stream mapping. Then you pick the different activities, what's happening where, what are the blobs in your process, where the actions are. So we can identify the agents, and we can have Dave, and we can have Bob, and we can have the different things. And then you can design your agent based in your technology, based on your processes, your input files to work for you. So we said this is one workflow. We just brought it as a demonstration, and it's actually implemented in Jira and GitHub Copilot, etc. So it's just one way of representing it. But when you identify the agent and what you want it to do, you have to build it. And first you have to design it. So no surprise, when designing an agent, I also suggest to take a test-driven approach. What the agent should produce. How good looks like. We are back to the Oracle problem. Actually, you should start defining a set of tests that will evaluate your agents. Now, evaluation is really focusing on the output. And you see I started from the right, but my point is bring testing forward also with the agents. So you have evaluation. Evaluation could be human in the loop. Human is reading, checking the output, and then saying, is it good or not good? And then if it's not good, how bad it is. All this information could go back to the agent, to the model itself, to learn from it, even to revise its own actions and do it better again in the same session. Evaluation could be, in software development, your whole pipeline. Because you have CI/CD, right? Because you have automated tests, right? And I'm seeing no nodding. Please. Testing is important. So you have your own software testing. Use that as the evaluation framework for your own software agents. And of course, the agent can be evaluated by another agent or another LLM or even itself. Asking a question, what do you think of your production, if what you produced, if this was your action? So evaluation is important, and that's why we start there. Set this up, the evaluation, and from there you can incrementally build your agent. So the agent architecture is from a lot of things, and this is in Microsoft Copilot Studio. You have the same. Atlassian Rovo Studio just came out, like they introduced it recently, 2 weeks ago. A similar agent building ClickOps thingy. But when you work with, for example, LangChain, you can build the very same things from code. And again, AI Foundry of Microsoft or Amazon Bedrock, not this, AWS Bedrock. I'm mixing up things. All the technologies are the same, roughly the same. So let's go through. First of all, you need to pick the LLM, right? You just learned that it's just a kind of smart predictor, right? It will tell you the next text. When was it? What's the learning date, right? How much information it has? How many parameters it has? How big knowledge it has? Was it created to talk or was it created to reason? Currently, I think in the Bedrock, there is like 1,600 different LLMs to choose from. Pick yours. Check the model card for the information and understand what you want, and is that LLM good for you? Maybe check the price level. That might be an important aspect as well. Good, when you have that, you start creating the prompt. This is your system prompt, right? All the prompting, and this is where we come into all the prompt engineering techniques, zero-shot, multi-shot, with examples, etc., etc. There are books about that. Read them, learn them. It's important knowledge. You will evaluate your agent's behavior based on the system prompt, and you will update your system prompt. When we go on, we need more information. We need more knowledge. Your agent needs to talk your language, your acronyms. By the way, Nokia is as bad with acronyms, right, as other companies. Some companies have the very same 3 letters for totally different things. So we built them agents to help them open up that in this context, in this document, that 3 letter means this. They are happy. They are using that with Conad, the elevator. I know it's public information. So it's important. And how do you do that? You do it through retrieval augmented generation. RAG, you probably heard another acronym many times, which is actually storing information in a similar way as the large language models in a vector database, and then can take information from that when they answer you with the answer. So it's like adding your context, your words, your terminology into the answer. Agents might have or might not have memory. Memory could be short-term, so within the cycle, or long-term between sessions. If you check your ChatGPT or whatever you use, Microsoft Copilot as well, in the settings, you will find the memory, what the agent knows about you. Sometimes you want to go through and delete some of those. And if an agent has a memory, but it's leaking between the context, it might tell the agent wrong things because, remember, it's the context. Like you switch conversation with your wife, family, and then suddenly that memory piece is not really fitting to the new conversation. I tend to do that a lot. So memory, designing that is also important. And then guardrails, sanitizing input, filtering harmful requests, but also output. If you don't want the agent to be autonomous and change things, make sure you have a guardrail not to let it do things. Or at least say you ask for approval before you execute the command. And how it can execute a command? Through tools, through skills, through MCP, another acronym, Model Context Protocol, right? With which we actually give tools to the agents so they can use those agents. It's like an API for agents. So knowing these is important. All of that is pretty important to design the agent. Now you understand your process, you know what you want to achieve, and now you have the elements, how to build it, and you have the evaluation, and you incrementally making it better and better and better.
Yeah, and then let's think about our agents again. They are working there happily together. They are coding, they are testing, they are deploying software. But how they can trust each other's work and how we can trust the results.
So you need an orchestration platform. You need a platform that is dealing with the messaging, dealing with the authorization, access of information, dealing with the MCPs, for example, and also logging everything that the agent did. You want to have the audit trail. You want to know what was the input, what was in the memory, what was the retrieved knowledge when you get something where the human in the loop says, I don't like it. Or when the code is produced is actually failing your test. So you want to have the information. It's just normal observability and telemetry. I'm again going back to DevOps. You want to know what's going on in your system. So you want to know what's going on in your agent. And you want to know what happened 2 months ago. So you need an orchestration layer.
Yeah, exactly.
So summing that up, we said we have 2 major problems, right? Oversimplifying, the communication problem and the Oracle problem. The communication problem is solved through the understanding what the agent should do, right? Understanding the process as well. So with that, you know what's the task. Go back to your process. Maybe give your process to the agent and ask, how would you generate an agent from this process? Context engineering, remembering the context, memory usage, prompt engineering. How your prompts looks like, how your system prompt look like. And then the guardrails, important for the information sanitization and filtering. And the Oracle problem, select the right model. what is the model that you know, what you need? What is the knowledge that you need? Where do you have that knowledge? How can you access it? Many times it's an interface development question, not an agent development question. And then, of course, the feedback loops. And all this is orchestrated through an orchestration platform.
There still are some fears. There are threats. There's a fear of job displacement. We have those security and compliance aspects to take care. And we need to think who is owning the AI and the results of AI. But
we discussed about quality. Surprise again, me. The quality of the agent. So just like I never trust software because I'm a tester, I will never trust agents. But what I can do with testing and checking all that, maybe I cannot prove it works. I can't prove it works. But it's a negative thing. So I can check if it doesn't work. I can try to show it doesn't work. And if I fail in showing it doesn't work, then I'm good with the agent. Anyway, point is, after I mixed you up totally, now we know how to build quality into the agent, how to build trustworthiness into the agent as well. And that helps us to actually climb on the levels and to get on a more higher maturity level to get the results and the benefits of AI. Thank you so much.
thank you.
And I think we left 4 minutes for questions.
Yes, if there is any questions, please let us know and I will bring the microphone. Okay? Sorry, I will go back.
Thank you. So you mentioned that the AI agents and the security compliance risks. So as of now, is there any compliance standard for the AI security which specifically looks into the security aspects of it? And just another part is, because one aspect of it can be that how do we deal with technically you can maybe implement things that this type of traffic should not be going outside of our network, or if some process is trying to access these type of logs, it can be an indicator. But let's say, how would you, can there be scenarios where social engineering is involved, that through which the AI can take advantage of it and it can, let's say, start leaking the data? Or let's say it's a chat GPT or something else and it is storing your code and then it's making a model out of it and sharing outside. Thank you.
Okay, loaded question. First of all, there's the EU AI Act, right, which is giving us a lot of directives about how to develop, what type of AI agents to develop, and most on the trustworthiness and the ethics part.
Yeah, and actually there's also EU AI Act agent to check the compliance with EU AI Act.
Yes. And then also, yeah, we can build, for example, this is a data protection officer agent. So you can have an agent to check, like, for example, how you are breaking code rules, like DPO rules, like privacy rules, etc., in your code. But then again, your agent is in the orchestration platform, and some of that is the orchestration platform, authorization, authentication, all those needs to be there. Who can access the agent? Who can change the code of the agent? And then from where the information gets there. So for example, if you have an MCP with an admin right to something, don't be surprised if anyone from the company is just deleting your whole database, because they can. So design that in. I hope that was an answer, at least for something.
So there was a question from here as well.
Let's play a role of a customer.
Yes.
I've heard your presentation, but I remember that this test-driven development is a rather old technological approach.
I said I'm in the business for 25 years.
In the 2010s, agile development came to the market. So if I am asking you as a customer, what will be your presentation for a customer who is really in has succeeded very well in the agile development practices. There, it is very important,
Okay.
the domain expert itself is included in the team.
Okay, so just
And this is very important, the customer tells, because I am quite old, a senior one, and I remember where in the 1980s, there was even a better way of development through data modeling, when the business entities were modeled together.
And the question is?
And the question is, what you are telling to this type of customer? Okay? Is it understood well?
Yeah, but I can start.
Yes.
So the idea here is that those basics of software development, they are not changing so much that people think. They think that AI is something totally different. But those DevOps is one agile methodology, and those principles are still valid, even if you are coding AI agents. So we don't have to change everything.
And then see this as not replacing the senior people and all the others. See this as enhancing and helping and supporting. And why we have the different columns in our representation as well. Every time an agent produces something, it's checked by the human. Moving it forward is by the team members. I don't see why this wouldn't work with Agile. I mean, I said several times DevOps, which is very much building an Agile and needs to be there. So all the practices, all of that should stay. I don't see that would change. What I see is that the senior expert will have a lot of little helpers for them to collect information, to understand the risks, to gather requirements, to clarify better the requirements, to make sure everyone in the team understands much better all the things. And one of my coder colleagues just stated that now with the Copilot, GitHub Copilot, they have beautiful documentation that they didn't have before because no one really wanted to write the documentation. Now the agents are starting with the text and only then do the task. So the documentation also states why these things are done. Maybe they are not perfect, but it's described why. So I think it will be very much integrated and helping the Agile teams as well.
Maybe just to give the chance to that side of the room as well to ask their questions for a last one for this team.
Hello. One short question. I was so happy to hear about this agent checking AI Act compliance because I'm a lawyer. And I'm asking if this agent is maybe helping lawyers or legal teams and IT colleagues to communicate, because this is essential in my opinion, and that would be great. So I'm asking how this helps.
Yeah, it is a really good one. I wrote one article on AI Act using only this legal text, and I'm not a lawyer, and it was really horrible. But then, we used this AI agent for that same tasks, and you can just ask, because I had my system is for predict work disability risk, and then I could ask from the agent that what is the risk level of my system, and what I need to do before deployment of this kind of system, and it tells me everything. Instead of going through the hundreds of pages of EU legislation.
But do you harmonize this with your legal team to double check if your agent is giving the right answer?
Yeah, of course, people must check it. The verification role is still on human, so we can't just trust the results from the agent, but we need to check it. Yeah.
The accountability and the legal consequences are on the humans.
Yeah, they are.
Still.
Not on the agent.
Still.
Yeah, that's still so.
That's the idea.
Yeah, but we need those humans and skilled humans for that.
Thank you.
All right, thank you very much, Katja and Szilárd, for this presentation. Give another round of applause for them, please.